Great. Thank you, Catherine, for the overview of the SAP. And again, to kind of reinforce, this section of the presentation is to provide that technical overview of different air monitoring options so that your input can be provided for the ELISA Funding Committee. And I will also provide an overview of these options as well as some concrete examples to provide some context. As you may know, there's not one box that can measure all pollutants for every purpose. So part of this presentation is to provide that overview that there is a wide array of air monitoring options and equipment, each with different strengths and different gaps. So this can provide some information so that you can provide input to develop the most robust and most beneficial to the community with your priorities in mind. So speaking about priorities, Catherine gave an overview of what the SEP conditions were, and a lot of them are embodied in these priorities, as well as they mentioned that they've been in communication with the Port Orange community and have heard some of the priorities. And this is an opportunity to make sure that the understanding of the committee of your priorities kind of matches that. And then from there, the monitoring strategy can be developed to be best suited for the air monitoring SEP. So the main thing is the pollutants of primary concern. Methane, of course, is a marker for natural gas. And although it's non-toxic in nature, it does provide a good indicator for the ELISA Canyon facility, even though methane has several sources, but the main source of concern would be from the facility. The next compound would be benzene and some of the other associated air toxics, or the BTEX compounds, which are known air toxics. They're a little bit harder to measure, but it's also listed into the SEP as well as listed as a community concern. Another is that the data from the air monitoring system must be in real time or near real time to provide information, and that information would go on a public data display. And that data display can also include some of the notifications that would come from the community, and as well as provide that real-time information coming from the air monitors, and then potentially can notify a listserv of people who are interested through email or other methods, depending on how much cost wants to be put in there, to provide that information when elevated levels would be seen. One of the things that drive a lot of this is cost. The more you add, or the different types of technology may cost different in terms of initial purchase price, as well as continuing the operation cost, which all affect the length of time for the air monitoring SEP to be active. So those are all things, with the assumption that the length of time for air monitoring would want to be maximized for this air monitoring plan. So I'm going to talk about 4 different air monitoring methods. The first one being monitoring stations, and also there'll be mobile platform measurements, open path fence line monitoring systems, and aerial measurements. I'll begin with the air monitoring station measurements, which are basically, as pictured here, essentially air monitoring station at one location, and it basically sucks in air through that particular location, and it can measure in real time. And the advantage of these instruments is that they generally have high data quality, especially when you're looking at methane and also looking at the BTEX compounds, and can provide that information in near real time. They can also be connected to a public notification system, which can be done and has been done in other communities. Some examples of this, at least of the fixed air monitoring, was exemplified when SS-25 was undergoing its leak, and South Coast, along with California Air Resources Board, deployed air monitoring stations at certain sites within the community that provided that information. Technology has evolved a little bit compared to what we had before. Some of the near real-time benzene that CARB had deployed is more proven technology now, and can be more within these type of air monitoring strategies, as well as what we had before in terms of if there are elevated levels, you can develop some systems that can collect samples that can be analyzed for the laboratory, as was done before. So that's kind of what you may be familiar with during that time, and that is one strategy that could be considered. The next is the fence line measurements, or open path. It is also continuous air monitoring at a fixed location. This does provide a little bit more spatial coverage because you are going from one location to another location along a fence line, as opposed to the air monitoring stations, which collect air at a single point. But what you do kind of gain in that coverage, I will speak, you do lose a little bit of that detection capability. It does work well for methane, but when you're looking at some of the components such as BTEX, they're not as good as far as detection power. So you may not be able to see those lower levels of the BTEX compounds. But they do have the advantage is that they do analyze faster. So you can probably get, if you're looking more for like 5-minute, 10-minute, or even lower time resolution to get information faster to you, this is a method that would kind of shine in that mode. And this also can be connected to a public notification system. In fact, let me get into some of the examples. I mean, you're familiar with some of them already that have been deployed. One that SoCalGas has operated one, specific for methane at different locations in northern Porter Ranch. And then, of course, since SS25, there was one that was been deployed by Argos Scientific, which is still ongoing, and they've provided their data and data platform system for the community. I will also add that we've had similar deployments as part of our fence line and community air monitoring for the refineries over in the Long Beach, Wilmington areas. So they have these type of systems to look at methane, but also for the BTEX compounds with some of the limitations that I mentioned earlier.